Okay, this video is for Learning Target 1 and 2. Actually, this video is just for Learning Target 1. There will be another video for number 2. But in these two targets, they're really connected because they're both different ways to count things, to count small events or big events. Some of the smaller events later in our probabilities, we will just count fingers and toes. But when the numbers are too large, we are going to need some of these counting principles and some of these counting techniques to count the large events. So what is Learning Target 1? We are going to use the counting technique of the fundamental counting principle, which simply says if event M can occur in M ways and is followed by event N that can occur in N ways, then event M followed by N occurs M times N ways. Simply put, if you have 5 choices for a pair of pants, followed by 4 choices of shirts to wear with it, then 5 times 4, 20, are the number of outfits you can make. The fundamental counting principle extends beyond just 2 events. If there are 3 events, then it would be blank times blank times blank, and so forth. So here are a few different examples. There are independent and dependent events. Independent events are when the outcome of one event does not affect the outcome of the other. So independent. At a deli, there are 6 options for bread, then an option of 6-inch or foot long. Next, you must decide between turkey, ham, chicken, and roast beef. How many sandwiches can you make? Well, there were 3 decisions. There was bread, there was size, and there was meat. So in this example, the fundamental counting principle has 3 events. You can choose 6 breads, 2 sizes, 4 meats. Multiply those, you get 8 times 6, you get 48 sandwiches. Number 2 deals with pizza. Pizza Pro is offering a coupon discount on their one-topping pizzas. The size includes small, medium, large, so size is an option. And the toppings include pepperoni, sausage, beef, chicken, black olives, mushrooms, peppers, and anchovies. That was 1, 2, 3, 4, 5, 6, 7, 8 choices. So the toppings had 8 choices. The sizes had 3 choices. 3 times 8, you can make 24 pizzas. And last, the one that most people struggle with, number 3, how many codes are possible if an answer machine requires a 2-digit code? 2-digit code. All right, digits are numbers. So you have a choice. What's the first number? And then you have a choice. What's the second number? Well, you can choose the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that's 10 choices. When you choose your second digit, according to this question, it doesn't tell you you can't use the same number again. So if it doesn't say you can't use the same number again, then assume that you can use the same number again. So if you had 10 choices for the first digit, you've got 10 choices for the second. 10 times 10, 100. And this is one of the few problems that you can actually logically think out. 2-digit codes. You could have 0, 1, 0, 2, 0, 3, all the way to 99, but don't forget 0, 0. So there's 100 codes. And those are independent events. Dependent events, if the outcome of an event does affect the outcome of another event, then the 2 events are dependent. You still use the fundamental counting principle, though. So here's an example, number 4. How many different schedules could a student who is planning to take 4 different classes, how many different schedules could a student have? Assume that every class is offered every period. So this problem is kind of like the block scheduling. If you know you're going to take math, you know you're going to take science, history, and social studies. Well, history and science. I can't even remember what I said now. English, math, science, social studies. There we go. If you're going to take those 4 classes, then how many ways can it happen? Well, you've got a choice for your first period, second period, third period, and fourth period. If you're going to take one of those 4 classes in the first period, you have 4 choices: English, math, science, or history. But as soon as you say, I'm taking English first, you're not going to take English again. So the second decision, the second event, is affected by your first choice being English or whatever it was. And you now only have 3 choices left to make for your second class. So if you then choose math, you have only science and social studies left. And then when you pick science, you only have social studies left. So dependent events affect the next decision. So this gives you what? 12 times 2 gives you 24 classes. And number 5, you and some friends rented 5 movies. You decide you're only going to watch 3. How many different orders can you watch the 3 different videos? This one gives a lot of people trouble, so I want to try to give you a visual. Let's say we have a kitchen table here, and it has our 1, 2, 3, 4, 5 videos sitting on it. So you're sitting at home, you and your friends went to the video store, you rented 5 movies, and now they're sitting on the kitchen table. You decide that you're going to watch 3 movies. How many orders can you watch those 3 movies? Well, if you're sitting there at your house about to watch movies, you're going to walk over to this kitchen table and you're going to pick a video. Okay? Then you're going to watch it. After you watch it, more than likely, you're not going to watch the same video again, so we'll assume that the problem's talking. You're not going to watch the same video again because you got to watch different videos. When you go back to the kitchen table, there's not 5 videos on that table anymore because you've already watched the first one. There's only 4 videos left. Agree? Okay. So let's say we watched movie 5. When we go back for a third and final time, how many videos are there sitting on the table? Videos 2, 3, and 4, just 3 videos. So translation is your first video, your second video, and your third video that you're going to watch. Those are the decisions. You have 5 choices for the first video. And as soon as you watch it, you only have 4 left for the second video. And then you only have 3 videos left for the third video. You're not going to pick a 4th video because you're only watching 3 movies. So 5 times 4 times 3 gives you 20 times 3 gives you 60. And the last example. How many license plates consisting of 3 letters followed by 3 numbers are possible when no repeats are allowed? All right, so we have choices. At this point, I'll introduce another concept, too, that when you're struggling to even understand where to start, I like to tell the students, I like to tell you all to try picking an outcome and get a feel for the problem. So let's do that on this problem. Let's pick a license plate. 3 letters, no repeats. So my license plate is ABC 1, 2, 3. Notice I picked different letters and different numbers because I couldn't repeat the numbers, couldn't repeat the letters. But I had 6 choices. 3 letters followed by 3 numbers. Now let's recap. When I said A, when I chose my first letter, how many choices did I have? How many ways could I have chosen the letter A or any other letter? I had 26 choices because there's 26 letters in the alphabet. But as soon as I said A, I can't use A for my second letter. So there's only 25 choices left. And then I can't use the B that I chose next. So there's only 24 letters left when I choose my final letter. Then we switch to the 3 numbers. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 10 numbers to pick from. But as soon as I said 1, for my 1, 2, 3, as soon as I said 1, I can't use 1 for my second number. So there's only 9 choices and then 8. I don't know this number, so let's pull the calculator up to help us out on this one. It's rather large. 26 times 25 times 24 times 10 times 9 times 8. 11,232,000. 11,232,000. Again, dependent events like these last 3. Once you've chosen your first item, does it affect what you choose next? In all of these 3 examples, once you chose your first item, you couldn't choose it again. So yes, it did affect. So that's the difference in independent and dependent. And that's learning target 1, the fundamental counting principle.